Hello dear students and welcome to today's video lecture. So today we are going to see program counters. So basically we'll just see some of the prior or the basic concepts and then we will move towards the program counter. So basically what is a program? Program is nothing but the set of instruction, right? We already know that. So computer program consists of sequence of instructions. So here you can see a diagram which consists of a computer program. So here these are the set of instructions which are written, instruction 1, 2, 3, 4, 5 and 6. So some instructions are longer and some instructions are shorter. If you compare all these instructions, some of them are longer and some of them are shorter. Like consider here, if you see this instruction 1 and 2, instruction number 2 is longer than instruction number 1. So computer program is basically stored in a program memory, okay, but we know that program memory is having the limited area, okay. Computer memory is having a limited area. So basically if you see the instruction is too long, okay, then it is to be stored in the separate locations in the program memory. So let's indicate here, you can see it here how the instructions are stored. You can see here instruction 1, it requires two locations because instruction is long, okay, so it is split into two parts. One of the part is stored in the location 0000H and second half of the instruction is stored in the location 0001H. It means these two are the locations which are required to store the instruction 1. On similar terms, you can see here the instruction 2 requires 3 locations. Why? Because instruction 2 was longer than instruction 1, and on similar terms we have stored the different instructions, and here you can see these are nothing but the addresses of program memory. These are nothing but the addresses of program memory, okay. So you just saw how the instructions are being stored. Now just have an overview about consider this is a CPU, okay. So CPU is having a program counter. You can see this is PC. PC stands for program counter, okay. In our case we are going to abbreviate program counter as PC. So you can see here the initial contents of program counter are 0000, okay. One more thing, you can see the CPU is having a IR. IR is nothing but the instruction register. So two important parts you can notice in a CPU are the program counter and the IR, that is instruction register. So once the CPU starts to operate, okay, its first step of operation is to fetch the instruction from program memory. So instruction is fetched from program memory, but from which location it will fetch? It will always fetch the instruction from the location which is indicated by the program counter. So right now the value or the address indicated by program counter is 0000. It means you have a program memory over here, okay. This is your program memory, and whatever will be the instruction at the location 0000, that will be fetched and will be stored over here in the instruction register. But this is not the complete instruction, okay. So as instruction from program memory at location 000H is fetched and is placed in the instruction register, okay. At the same time this program counter is now incremented by 1. So from 0000 it will become 0001, okay, it will become 1. So CPU here will go into the decoding cycle. Only half part of the instruction 1 is received because we have already seen instruction 1 requires 2 location, okay. So only half part is received here. So CPU is unable to execute this incomplete instruction because it is not completed, because half part is still remaining. So CPU goes back to the fetching cycle. Instruction is again fetched from the location. Now from which location it is going to fetch? The location which is indicated by the program counter. What is the location indicated by program counter? It is 0001. So from 0001, it means from here it will be location 01H now. Okay, this will be fetched and will be stored here in the instruction register. Okay, so instruction is again fetched from the location which is indicated by the program counter, that is 0001H, and again the PC is incremented by 1, so it will become 00002H. It will become 2H. So we say that program counter is incremented by 1 and CPU then goes into the decoding cycle. Now instruction in IR is complete. Why it is complete? Because we know that instruction 1 was requiring 2 locations. So here 2 locations are being complete. Now the CPU is able to execute this instruction. So after completion of execution cycle, the CPU is ready to fetch the next instruction, and the same process is repeated. Okay, unless and until all instructions of your program are completed. It means PC is always incremented by 1 after each fetch cycle. Then CPU is going into the decoding cycle and then the instruction is decoded. Okay, now suppose if you just assume that instruction required to jump to instruction number 5. Okay, why instruction number 5? See, this is your main program and it consists of different instruction. So whatever you have instruction number 5, if we want to jump from instruction number 1 to directly 5, we want to skip this. We want to skip the in between instructions. So at that time the address 0008, okay, when executing the contents of CPU changes its contents in PC. It means whenever we want to jump from this location directly to this location, okay, you have to change the contents of this program counter. Then and then we can jump. Okay, but it is possible. Okay, so I'll just tell you in short about whatever process we saw. I'll just summarize this process. So instructions are usually fetched from the location which is indicated by the program counter. So after every fetch cycle, program counter is incremented by 1, and if the instruction is not complete, additionally instructions are fetched. If instruction is the jump instruction, then the CPU has to change the contents of program counter. Therefore, what exactly is the function of program counter now? Function of program counter is always hold the address of next instruction which is to be executed, okay. So you can see here some important things. Computer program consists of the sequence of instruction. It compares each instruction. You may find some instructions are longer and shorter. Computer program is stored in the program memory, where program memory has limited space, and if the instruction is too long, it has to be stored into the separate locations. So these are now the important things about the program counter. Program counter in PIC 18F458 family is a 21-bit register. So the maximum addressable program memory is 2 raised to 21. 2 raised to 21 is equal to 2 MB. It means each location is going to store 1 byte. Okay. However, 18F family has only 32 KB. See this, it is important. It has only 32 KB on chip program memory. Okay. It means its addresses will be from 00000H to 07FFFFH. Okay. So program counter always hold the address of next instruction which is to be executed, and it is incremented automatically when CPU fetches from the program. Okay. So here you can see the structure of program counter. Program counter is basically split into 3 parts. You can see PCL, PCH and PCU. PCL means program counter low, PCH means program counter high, and PCU means program counter upper. Each of them are of 8 bits respectively. It is PCL is equal to 8 bit, PCH is equal to 8 bit, and PCU is equal to 8 bit. But you can see amongst PCU these 3 bits are unused. Okay, it means from these 8 you have to subtract this 3 bits. So 8 plus 8 plus 5 is equal to 21. So program counter is 21 bit. But what is the necessity of splitting the program counter in 3 sections? So if we want to manipulate, that is jump manually from one place to another, okay, or change the flow of program, like program counter is usually automatically incremented, okay. So in order to do it manually, this is splitted into 3 parts. So this is just the structure of program counter. It is the most important point, okay. So see, this is the nature of how the program memory usually looks like, okay, because as far as program counter is concerned, it usually fetches the data from a program memory. So just we'll see in short about the program memory. It is 8 bit wide, okay, it is 8 bit wide. So basically usually on reset, program counter holds the address 0000H, you can see here, okay. Therefore the first opcode of instruction in the program must be burned into this location only, okay. So this is achieved using organization instruction in the program. So each address in the program holds 1 byte. I told you it is 8 byte. 8 byte is equal to 1 byte. 8 bits is equal to 1 byte. So it holds 1 byte of data, okay. So program counter is basically used to fetch the data from the location whichever it is pointing, okay. So you can see here how the program memory is being organized, and its maximum location is 1 FFFFH, okay. So this is all about the program counter. Important highlights about a program counter: basically program is nothing but set of instructions. So these instructions are usually stored in program memory, but from which location you have to fetch the instruction is being indicated by the program counter, where program counter is always incremented by 1. It is a 21 bit register. 21 bit register is then splitted into 3 sections: program counter low, program counter high, and program counter upper, where program counter low is of 8 bits, program counter high is of 8 bits, and program counter upper is of 5 bits. So in all it is of 21 bits. Thank you.